So hello everyone, welcome to another particular lecture of our radical chemistry course, and this is the last lecture of our radical chemistry course. And in this particular lecture we are talking about the radical name reaction. So from the lecture 5 onwards we have discussed about the different kind of radical based reaction such as the chain reaction, then tin hydrate mediated reaction, and in this particular reaction class we mainly focus on the name reaction. So we begin with our name reaction with the McMurry reaction. McMurry reaction is a reaction between a carbonyl compound. That carbonyl compound is treated with a titanium trichloride or titanium tetrachloride or a reducing agent. Mostly metals such as lithium, sodium, magnesium, zinc, copper has been used to generate olefins. So this is the typical McMurry reaction. So let us understand the mechanism of this particular reaction. So the initial mechanism is to reduce this titanium chloride. So the titanium trichloride with a reducing agent, here use the potassium to generate the titanium dichloride or Ti2 plus KCl. Now in some books it has been mentioned that by using this reducing agent, titanium plus 3 or plus 4 directly reduced to titanium 0. But here in this particular mechanism, it has been written this go via initially plus 2 and then it will go to titanium 0 via in situ methods. So what happened that this titanium dichloride having the electrons, and this electron will go via set mechanism or the single electron transfer mechanism to the carbonyl compound to generate this type of radical, and the other electron present in this particular moiety will go to another particular carbonyl compound to generate this type of radical. Now these two radical prepared, and now these two radical getting combined to generate this particular 5-member ring. And now here you can see that in situ method, this titanium dichloride will now convert it to titanium 0, and now this 5-member ring got rearranged or getting break apart to getting our corresponding olefin and titanium dioxide. Okay, and if we talk about the stereochemistry, so usually it is found that McMurry reaction normally yield trans olefin because of the steric issues. So that's enough for the McMurry reaction. Let's move on to our next radical based name reaction. So the next name reaction is the Barton decarboxylation. Barton decarboxylation is an important reaction where you have an acid moiety and you generate a alkane moiety from the acid derivative. So Barton decarboxylation is one of the useful reaction to do that particular transformation. So what happened that initially particularly acid group or acid moiety, carboxylic acid moiety, can be treated with the SOCl2 to generate the acid chloride part. Now this acid chloride will react with this particular compound to generate that thiohydroxymate ester, and this thiohydroxymate ester becomes the starting material of the particular Barton decarboxylation process. And now what happened that this particular thiohydroxymate ester will undergo a tin hydrate mediated reaction to generate our corresponding alkane plus carbon dioxide, and our this particular starting material getting back with the tin hydrate variable. Okay, so the mechanism, if we look about that, this thiohydroxymate ester if treated with the tin hydrate mediated reaction, initially this particular bond breaks apart and this radical will getting rearranged to generate the decarboxylation pathway, and keeping this particular R radical in the medium, and this particular R radical will take the proton from the unused tin hydrate part and take this particular hydrogen to generate our corresponding alkene. So let us understand deep down the mechanism of this particular reaction very well. So this part is very much clear, like acid chloride to thiohydroxymate ester formation. Now let us talk about the tin hydrate mediated reaction pathway. So first is the initiation part, that I hope that you are all familiar with the initiation part in the tin hydrate mediated reaction. If not, then I would suggest you to go to the previous lecture and then we'll You will understand. So first, the initial step is the initiation. This particular AIBN getting initiate this particular radical, and this radical will propagate the chain reaction, because this particular radical will react with this particular tin hydride complex to generate this radical, and this radical will be the starting radical, or the radical of interest of propagation pathway. Okay, so this particular radical will now attack here to this particular uh, hydroxymate ester sulfur center to generate this radical, and this radical will now go undergo a certain rearrangement, like this particular bond breaks apart, and the cleavage of this particular bond, and these two radical combine. Okay, and this particular radical now go via this pathway to getting a decarboxylation pathway to generate this particular R radical, and this R radical will now quench with another tin hydride complex to generate our corresponding alkene. And this is the mechanism of Barton decarboxylation. So let us talk about some kind of example. So here you can see that this type of compound is there. We treated with this particular tin hydride mediated compound to just remove this particular part, and here this particular group has been replaced by a mere hydrogen group, and we getting our corresponding alkene. Now similar type of reaction with a different name suggests, that is the Barton McCombie radical deoxygenation. This particular reaction is nothing but a similar version, but here you can transform a alcohol to an corresponding alkane by treating this particular compound with this type of compound. Okay, so what happened that this particular alcohol will react with this compound uh, to generate this type of starting material, and this starting material will undergo a tin hydride mediated reaction to generate our corresponding alkene. And the mechanism is similar like Barton decarboxylation, like alkene. Now let us talk about some other name reactions like Hunsdiesker reaction. Hunsdiesker reaction has been used to generate this type of carboxylic acid to a corresponding halogen by reacting with the silver oxide and the corresponding halogen. So what should be the mechanism? Mechanism suggests that first this silver oxide getting hydrolyzed to get the AgOH and HO plus Ag plus, and this hydroxy and Ag plus will have a significant role in the particular mechanism. Like here what happened that this OH minus will grab this particular OA H here, because this H is acidic enough to take this particular, and this particular negative will rearrange uh, or we can say undergo resonating pathway to generate this type of intermediate. Now this intermediate will again goes down to react with some kind of bromine part. Okay, now here till here there will be no radical step involved, but by preparing this particular compound, now the radical pathway got introduced. Now this particular can undergo two different pathway. Okay, so the first pathway is this this particular bond get cleaved, and this particular radical will undergo decarboxylation pathway to generate our this radical, and this radical will now combine the Br radical present in the medium. Like after cleaving this particular bond, we got our Br radical, and this Br radical and this particular radical got combined to generate our corresponding halogen part. Or we can say that this radical, okay, this radical already, if this radical present in the excess amount, this will directly act as a propagation step of this breaking down this particular bond, so that this radical will initiate the bond breaking process between this OBr and this will take the Br and leaving this particular radical there, and this particular radical will go again the decarboxylation pathway to again regenerate this radical. So we can say that a chain reaction has been continued from here. Okay, now let's talk about another very important reaction that in terms of exam point of view, that is called the Acyloin condensation. Acyloin condensation has been observed between a two ester compound in presence of a sodium metal and a xylene as a solvent to generate 1,2-diketo compound, or after acidic workup we can say that this 1-hydroxycarbonyl compound has been generated by this Acyloin condensation. So first let us talk about some kind of examples, and then we are talking about the mechanistic pathway of this particular Acyloin condensation. So what happened that this particular example you can see here, that this is one of the esters which react with this particular sodium and xylene compound, then this type of diketo has been generated. Also, Acyloin condensation can be go via a intermolecular pathway, where if one compound contain two different ester centers, then in presence of sodium xylene, it will go via this particular pathway. So initially, it will form a cyclic diketo compound, and after that, this acidic workup, it will generate this type of compound. Similarly, it has been found that it might prepare a four-membered ring also. Also, we know that the four-membered ring is highly strained ring, but still, if there is a possibility, so it will form this type of four-member structure also. Now, let us understand the mechanism of the particular reaction. So, the mechanism is initially our ester is there. The ester is react with this particular sodium. What happened that in particular solvent medium, it will liberates one electron, and this electron will attack here to keep this particular bond up. So we'll get one radical here, and the radical present in the O, or we can say the negative charge, will be stabilized by this particular sodium metal. And similar fate will be done with the other particular ester moiety to generate this type of radical. So it is like similar of the McMurry reaction pathway, but in the McMurry part we are actually dealing with the uh, complete carbonyl compounds. Here we are treating with the ester compounds. Okay, so what happened that these two radical getting combined to generate the new carbon-carbon bond here, and after that we know that esters are OR are the good leaving group. So what happened that this particular negative charge return backs to kick out this particular ester group from both the end to generate this diketo compound. Now some reaction will getting stopped in this particular step, but if the particular medium contain extra sodium metal or having the possibility of an acidic workup, then it will go on a tautomerization path. So what happened that if the present medium contains the extra sodium metal, so what happened that this type of thing has been generated again, and then it will go on an acidic workup where this particular ONA bond ionic bond flipped to generate the dihydroxy compound, and then one of the dihydroxy compound getting tautomerized to get our desired final this compound. So I hope you understand the mechanism of Acyloin condensation. Now let us talk about another very important reaction, especially in the photochemistry pathway. There is the Barton Nitrile ester reduction. Barton Nitrile ester reduction has been observed when the particular this is the starting material. Okay, so this starting material will initially generated from an alcohol by treating with the NOCl in presence of pyridium or pyridine. So generate the ONO compound, and now it has been found that there is a 1,5 hydrogen transfer takes place like 1, 2, 3, 4, 5. So basically this NO travels to the fifth position, or we can say alternatively that one of the hydrogen present in the C5 or the fifth position in terms of this particular NO group, okay, gets swapped. Like this particular hydrogen will come here and this NO group come in the fifth position. Okay, and we get this particular group in presence of light. So this is called the Barton Nitrile ester reduction. Let us understand the mechanism. Like initially this starting material preparation is very much easy, okay, very much convenient we can say, and after that what happened, this particular bond breaks apart, and also this radical will catch up this particular proton present in the fifth position in terms of NO. Like this is 1, 2, 3, 4 and 5. So this bond first cleaved and then 1,5 hydrogen abstraction takes place. Now you may be think that what is the special about the fifth position hydrogen, because there is a one possible explanation of this, that while taking abstracting this particular fifth hydrogen or the fifth position hydrogen, we can say that there is a 6-member transition state is formed there, and which makes the particular transition state very much stable. Okay, and for that particular reason mostly this particular fifth hydrogen can be captured. So what happened that if after capturing this fifth hydrogen, so there is a one radical form here, and also due to this cleavage of this particular ONO bond, okay, this NO radical also present there. So these two radical will combine in situ manner to generate our this particular compound, and then a tautomerization happen to generate our corresponding NOH compound, or our desired product has been generated. So here you can check one of the example. Okay, so here this particular compound is there, OH is there. First NOCl will react to generate the ONO compound. Okay, now we have to find the fifth position which contains hydrogen. So this is 1, 2, 3, 4 and 5. Okay, so if we go here 5, then what happens, this particular fifth carbon doesn't have any hydrogen to undergo 1,5 hydrogen abstraction, so this will not there. So similarly we can't go this pathway because here also no hydrogen is there. So the our desired pathway will be this only, because here one hydrogen is there. So the simple remember of this particular the simple hack of this particular reaction is you have to find the fifth hydrogen, and then you have to just completely swap. Like here it contains a hydrogen coming from here, and this particular NO will combine here, and after tautomerization we will get our this product. So with this we have to end our radical chemistry pathway, radical chemistry course. So thank you for listening all the particular lectures, and also the materials, study materials, as well as the some kind of materials are given in the description box of each video, and also in the playlist itself there is some kind of material attached. So I hope that this will be enough for your examination purpose, although I believe that there will be very vast thing is there if we actually deep down in the radical chemistry pathway. But since our motive is to give you the just the required amount for your examination purpose, so I believe that this is enough for your examination purpose. So I hope that I will bring a question answer video of the radical chemistry course. So thank you for listening this particular course.